So, I need you to find in your packet, there is a sheet, and it's kind of cut off at the top, but it says Review 2.6 to 2.10 Study Session. It's handwritten, has a box, has some asterisks on it. All right, so here we go. We're going to go through these problems right now. Get this straightened out so we are ready for this test on Thursday. So, just going to go in order. The ones that have stars next to them are calculator problems. So they don't start till number 5. So we're doing no calculator. Here's problem number 1. What am I going to do to solve this?
Multiply the denominator by 4 times x minus 3.
I'm going to multiply every one of these terms by 4x minus 3. 4x minus 3. Every single one of them. These are GTQs, guaranteed test questions, so let's just get through it, okay? Here we go. Cancel out what'll cancel, 4x plus 20. Cancel out what'll cancel, x squared minus 3x. And 12x minus 8. Everybody good up to here? Yep. Now, what kind of equation is that? So what do I do with quadratic equations? Get them set equal to 0. So we got some collecting like terms to do. You double check my arithmetic for me. And that worked out great. Somebody planned this problem very well. X is 4 or 7. Can I keep both of those?
No.
Yes. Absolutely I can. What is the only excluded value? 3. That's not 3. So those are both answers to the problem. All right, number 2. Step 1. Get 0. We like to have 0 in our inequalities. Now what? Factoring. In this case, that's just taking out an x. Now what? Number line. Where will the dots go on the number line? These will be closed dots at 0 and 5. Now I'm going to pick a number. 2. If I put 2 in, it doesn't matter where I put it in, I'm going to put it in right here. If I put 2 in, I get a positive times a negative. Does that work for me? Yep, so that works. So my answer is everything between 0 and 5. Since there's nothing squared here, or square roots, or absolute values, or anything odd, I can trust my alternating thing. But if you are concerned about that, you're going to try numbers in these regions too, right? That's how you can always tell exactly where it's shaded. All right, number 3. What's our strategy here?
Subtract 6.
And get 0 again. That's what we do. We get 0. I've got Alyssa absent back there.
That is correct.
Yes.
And Voodoo. Really? Okay. All right, so you said subtract 6, you're right. Get my 0. And then what? Multiply this one by x minus 1 over x minus 1 so that we can write one fraction. On top we'll have x plus 2. Now be careful. Minus 6x 6. So negative 5x plus 8. Now I need 2 dots on my number line, right?
Yes.
This one I can tell is at 1. This one's a little freaky, so I'm just going to go ahead and work it out. That's going to be at 8/5. So I have 1 at 1 and 1 at 8/5. They should both be closed, but the denominator can never be closed. So 8/5 is closed, but 1 is open. So I'm just going to use 0. I'm going to put 0 into my fraction. It makes the top positive and the bottom negative. Is that what I wanted? No. So I don't shade 0, so I must shade here. So the answer is everything between 1 and 8/5. Number 4. What are you going to do with number 4? It's already got 0. Yeah, we need to factor it. It doesn't factor by grouping, so we'll PRR it. No, it doesn't. I mean, you can factor things when you group it, but what won't happen? You'll get the same parentheses, so. Let's see, I'm trying to see what might work. I think -1 works, so let's try -1. -1 is a PRR. Sure enough. So what do I do now? Now I know -1 works. So what do I do now? Take this guy and factor him, and he factors as, whoops, 2 and 4. Now where are the dots going to go on the number line? Remember, your job is to solve that inequality, so you're going to have shading and stuff going on the number line. Where are you going to put the dots? At -1, at 2, and 4. Do not forget the -1 that you found first. Furthermore, do not forget there are 3 factors. These 2, and then what? What's the other factor? X plus 1. Those are the 3 factors that have to be less than 0. So let's just try 0 again. It doesn't matter. Pick a number, any number. I'll just do 0 again. So 0 gives me positive, negative, negative. When I multiply that together, positive, negative, negative, what do I get? Positive. Is that what I wanted? No. So that doesn't work, which means this does, and this does. So your answer is everything less than -1 or between 2 and 4. All right, now I'm going to skip to 9 because I'm going to do all the no calculator things. So I'm skipping to 9. What are the excluded values for this equation? You're not solving it, you're just saying x cannot be 3, -3, or 0, right?
Yep.
Those are your excluded values, 3, -3, or 0. 10. Sketch this guy, all right? So the first thing we're going to do, it's like your quiz yesterday. So the first thing we're going to do is see if we can break our problem down at all. Well, it looks like we can, right? Two out. I think that's right. And the first thing you notice is you've got a cancellation, which means you're going to have a hole. And the hole will be where x is -3. Right? So we'll put -3 in up here, and we get -7 over 2 times -4. 7/8? Huh?
Yeah, it's like -3 and you put it on the
Oh,
positive
yeah.
side.
Yeah, thank you. Plot it in the right place. All right, now, what else do I have? This is what I'm graphing now. What else do I have?
You have a horizontal asymptote.
I have a horizontal asymptote at 1/2. How do I know it's a horizontal asymptote and not a slant asymptote? The powers match. The powers match. X squared over x squared. I have a vertical asymptote at x equals 1. Where's this fraction equal 0? At 4. What do I get if I put 0 in to the problem for x? 2. Is that enough to sketch it? Probably. But if it's not, what can you always do? Yep. Now we want to use limit notation to describe all the asymptotic behavior. So what happens when we go to infinity? What happens when we go to -infinity? What happens when we approach 1 from the positive side? And what happens when we approach 1 from the negative side? So that'll take care of all the asymptotes.
Which one has the bottom?
As we head toward infinity, what is our curve doing? Getting closer to 1/2 from the bottom. What about as we approach -infinity? You're still getting close to 1/2, but now you're coming in from the top side. Now what about as we approach our vertical asymptote? From the right side, as we approach our vertical asymptote, what are we doing? -infinity. How about from the left side, heading toward the vertical asymptote? Positive infinity. All right, now we're going to use our calculator on all the rest of them. So let's just take care of number 11 while we're here. Now, this this is an equation. So if you'd rather times everything by x, you're allowed. So if you would rather get rid of the fraction, now you're going to go to your calculator either way, so it truly doesn't matter. But you might like the looks of the picture better if you just multiply through by x. Is that okay with everybody? You do not have to do this, but if you want, you can. Now, I'm going to graph that on my calculator, and what will I be looking for on this graph? What feature am I looking for? The zeros. So I'm going to just graph it. I'm going to start in a standard window because I really don't know what it looks like. And I got a picture that looks kind of like this. Did you get something that looks like that? So we are interested in that point. And I got about negative 0.67. Now again, you did not have to do this arithmetic to get started, but it makes your picture look better. This one's going to have asymptotes. It's going to be 2 pieces because of the denominator. Since it's an equation, you're allowed to multiply by x. That's not a problem. Okay, number 5. Create a box like usual. See, I'm just too lazy to write it all out. You know what's happening, right? We're ripping the corners out, folding up the flats. Okay. Paper's 10 by 12. And we want the volume to be at least 80. So what's our equation for the volume of this box? The paper's 10 by 12. Jake?
X times multiplied by 10 minus 2x multiplied by 12 minus 2x.
Yep, there's the equation for the volume. Now we want the volume to be at least 80. So when I graph this in the appropriate window, because this is a real life problem, it has context, you can't just graph it. When I graph it in the window from 0 to 5, that's the appropriate window because the paper is 10 inches across. I'm going to get a parabola looking thing. It's not a parabola, but it looks kind of like a parabola. And then I'm going to graph 80 right on top of it because somewhere on here is 80. And if I want the volume to be at least 80, aren't I looking for this part of the picture? So what do I need to do on my calculator? I need to find these 2 points, and then my answer will be everything in between them. So I'm going to graph both of those equations separately. This nice picture. I used 0 to 5 and 0 to 150. And I got that nice little picture. And I'm looking for the intersections. Oh, this one's at 1.
Oh.
other one is at about 2.76. So how do you answer the questions? Find the size of the cutouts that will produce a volume of at least 80. X is between 1 and 2.76.
Mine is a third.
Okay. But it's bigger than 5, right?
Yeah.
You gotta keep in mind the context of the problem, right? That's why when you do a box problem, you should never graph more than the domain. 0 to 5 is how your x's should be set. You cannot take more than 5 inches off of each side of a 10-inch piece of paper. So whatever other answer there might be, it can't possibly work. Jasmine?
When I graphed this, instead of going like this way, it went that way.
I don't know. That's the equation you
That's
have to
what
put
I
in.
wrote on page 6.
Okay, I'll look at it later.
When you write the answer to the equation, would it be like greater than or equal to 1 and less than or equal? Oh wait, I can't read.
All right, number 6. We've got some juice and we're gonna make some more juice. All right, so what's our strategy? Problem 6, what's our strategy?
Amount times percent.
Thank you.
So it's amount times percent.
You're gonna feel awful foolish if you miss this, people. All right, so we got 12%, we got 18%, and we wanna end up with 14%. All right, what's the amount that we know? 50 gallons total. The question is, how much 18% juice? So I'm gonna go ahead and call that X. What would this be then? Remember, they add up to 50. So what would this one be? 50 minus X?
I
Jake?
just want to make sure it doesn't matter.
No, but it's gonna be easier for me to call this one X because that's the question.
Yeah.
So when I solve it, I'm gonna get X equals.
Yeah.
But it doesn't make any difference in terms of getting the right answer. Your hand up, Evan?
No, sorry.
Okay. All right, so here we go. We got 6 minus 0.12x plus 0.18x equal to 7. So 0.06x equals 1. And I got about 16 2/3 gallons. My arithmetic look okay? All right, now we got Rachel and Emma doing homework. All right, so what's the setup for this gonna be? Rachel takes 3 hours, so 1 over 3 plus 1 over x equals 1 over 1.
Yep.
How do you solve that?
Yeah.
Multiply by 3x. Would be one way. You don't have to do it this way, but it's the way we've been doing it. So x plus 3 equals 3x. So how long does it take her to do it alone? 1.5 hours. Three halves, 1.5 hours. And finally, number 8, last one. We're gonna minimize, or find a minimum area for this piece of paper. I have to have 120 square inches of print. I got 3, and 1.2, and 1.5. Remember doing one of these yesterday?
Yes.
Yeah.
So we need an equation for the area of the whole thing. I know the area that's 120, but the area of the whole thing. So I need to know this dimension and I need to know this dimension. Because that times that is how I'll get the area, right?
Yeah.
So tell me about that. Jake?
Are we saying this in parentheses?
Well, yeah.
It's x plus 3.2.
Okay, what is x? What did you let x be?
Blank.
Of what?
I let x.
Where do I put x in my picture?
On those little squiggles.
There's
No.
smaller box.
On 120.
Janae?
Would it be like under the 120?
This could be x, right here, that could be x. This could also be x, it doesn't matter which one, but one of these is x. And then what's the other one? 120 over x. Because these two times each other have to be 120? So my length, if I let this be x, then this dimension is 3 plus x plus 1.5, or x plus 4.5. Now that'll be different if you let x be something else. But if this is x, then the width of this paper is 3 plus x plus 1.5. What's the length of the paper? 2 plus 120 over x plus 1.2? So 120 over x plus 3.2. Those are my dimensions by defining this as x, and that's 120 over x. Now I'm going to graph this, and what do I want to know about it? I want to know the minimum.
Oh, yeah, that 1, 2.
So I'm probably going to have to play around with my window. Until I see a minimum. Because my calculator's set from the last problem, I'm not seeing anything. All I have to do is be able to see a low point. So I set mine up from 0 to 50 and 0 to 500, and I see a definite minimum. So I'm going to find that minimum now. I got my minimum to be 12.99, comma 217.54. Any confirmation?
Yes.
So I want to answer the question. Minimize the size of the paper. What do you think that means? What would I be wanting if it said minimize the size of the paper? What do you think I want?
The area? The smallest area.
I want the smallest area, but if I want to, I want the dimensions. What are the dimensions that are going to give me the smallest area? So I'm going to take this 12.99 and add it to 4.5. So 17.49 by what? What's the other dimension gonna be? 12.43 or 44. So I need my paper to be about 17.49 by 12.44, and that will produce that area. Okay, let's get our quizzes back. These were 15-point quizzes. We're going to go over them here.
So still ask her where she said that if there's a zero, you have to figure it so I'm sorry, asking which one that's right.
No, we don't have to because it was a good girl on your job.
Was it worse than Stammer? Higher or lower? 17.
Can't believe I got that. How much later?
Sarah,
No, I excited myself out because
all right, let's go through this. Some of you did magnificently. So, those of you that scored 15, 16, or 17 may totally ignore me and begin your homework, which is practice or review sheet 2. All right, so if you want to start review sheet 2, you may do that. If you did not get a 15, 16, or 17, your beady little eyes are focused on me because we're going to get this right on Thursday. Okay? So, here's your problem. How did you begin? You factored it so that you could hopefully cross some stuff out, reduce the size of the problem. So, yeah, you may sit over here. Yeah. So we'll take a 2 out. And now we're going to factor. And I've already gone into a rant once today, so I'm not going to do it again. I am simply going to say that there is no reason seniors in high school should be factoring incorrectly, and some of you are. As soon as you factor, I want you to FOIL it back together. I do it. I'm old, and I still check myself every single time. When I FOIL this back, it gives me what I wanted. Those of you that said x minus 6, x plus 1, that does not give you what you want, because when you multiply these, you get a negative 6, not a positive 6. You would catch that if you took the time to check. You can do a mental check in about 10 seconds. Well, we got a cancellation. So this is what you're going to be actually sketching. Okay? But because we had a cancellation, we know we're going to have a hole. So let's take care of that before we forget. The hole will be where x is 3. So I'm going to plug 3 in here. And what do I get? 2 times 5, I get 10. So I have a hole at 3, 10. Everybody with me?
no.
Why did you not get 3 comma 10?
I got 3, 0.
I don't know how you did that. Because
don't
when you
either.
put 3 in here, 3 plus 2,
Oh, I didn't know
Times
we had to
2?
plug it in.
yes, that's where you plug it in. Now you know, right? That's where you plug it in. Okay. What else do I have here now? This is what I'm graphing. What else can you tell me about it? I have a vertical asymptote at 2. And I have a horizontal asymptote at 2. How do I know this end behavior asymptote is horizontal? Look at the original problem. What can you tell me about the x's? They match. And when the x's match, your end behavior asymptote is going to be horizontal. It's only not horizontal when what happens? The power on top is bigger. Is there anything that makes this fraction equal 0? Yes, -2. That's your 0. What happens if you let x be 0? -2. Coincidence doesn't always happen. Is that enough to draw the picture, or do I need to plot points? Some of you plotted points, and that's good if you need to, but I think we have enough. Don't forget you got your hole up here. There's your picture. Now, before we start all this limit stuff, does anybody have a question about the picture?
I have one question.
What?
So the VAs are on the bottom and the x-intercepts are on the top. Oh no.
Yes, but I wish you would understand why that is.
Yeah. That's what
Vertical asymptotes are things that x cannot be. So of course they come from when the denominator is 0. But yes, vertical asymptotes are generated from the bottom of the fraction. X-intercepts are generated from the top. All right, so now we're going to run down through all these answers. All right, here we go. X approaches infinity. This is the picture that we're using. X approaches infinity. Where does that happen? X approaches infinity. Yes, JR is pointing that way. So put your pencil on your curve and start going that way. What are you doing? What's happening? You're getting closer to 2 from the top. Now what about as you approach 0? Now wait a minute. 0 is a point on the graph. Where x is 0 is a point on the graph. The y coordinate is -2. Remember, these are y coordinates. The limit values are y's. What's happening to y? You already know what x is doing. So what happens to y when x gets closer to 2? Well, wait a minute. 2 is an asymptote. When you come at an asymptote, you can't cross it, you can't touch it, so what do you have to do? You're either going to go up or go down. So what are we doing as we come at 2 from the left side? As we come at 2 from the left side, we are going down. Negative infinity. X is going to negative infinity. Where does that happen? Where does x go to negative infinity? That way. So get your pencil on the curve and start going that way. What are you doing? What are you doing?
2.
you're getting closer to 2, but this time you're getting closer to it from the bottom side, from underneath. Now I want to get closer to the asymptote again, but I want to come in from this side. What am I doing when I come in from this side? Positive infinity. Now I want to go to 3. Wait a minute. 3 is not an asymptote. 3 is a dot. It's an open dot, but it's still a dot. What's the y coordinate? If x is 3, y is? Any question about that? All right, your homework tomorrow is the second review sheet 2. I would suggest we do it.